everybody, this is Tony and I do stuff. My motorcycle, like most bikes these days, at least the high-end models, has a tire pressure monitoring system built into it. These systems depend on sensors that are contained inside the tire, and they are battery operated. My 2017 K1600, the batteries are starting to give me intermittent service. I have seen it read as high as 70 psi. Sometimes I get readings, sometimes I don't. I even saw the tire pressure monitor turn red once. BMW, which I think stands for Bring My Wallet, wants about $150 each for these tire pressure monitors. I'm kind of cheap and a little bit adventurous, so my solution is to go in and see if I can replace these batteries. From what I can gather on the internet, these are generally CR 2030s, or batteries that are commonly used in other things like watches, radio control fobs. So I'm gonna pull the tire off and take the monitor out, cut it open, and see if I can replace this battery. I'm taking you guys along with me. Here we go. The monitor's held in place with a T40, one of these Torx, and it's got a hole through it, obviously, for the air to get through the valve stem. It's got some Loctite on it to make sure that I don't get them mixed up. A few weeks back, I took the rear sensor out and dug the epoxy out of it. It wasn't much. It's kind of a rubbery type epoxy. It's somewhat flexible. I thought that weight would be an issue, but is very insignificant. What I found was that it doesn't have a standard battery in it. It has a CR 2050HR, which according to the descriptions that I read, is a battery made to survive in a high temperature, high pressure environment. I went to Batteries Plus. Batteries Plus looked in their inventory. Obviously it wasn't on the wall. They checked their computer and said, we can order this for you and it'll be here in a week. I got a call a few days later and they said, hey, we don't have this thing, we got to special order it, and there is no delivery date, so we have no idea when you're going to get this. I went online to eBay, and eBay has everything, and I found these things in a package of 5 for $22.91. Now it took 16 days for them to get here, and they came with this really neat little note in very broken English, so I'm figuring this is a Korean company or Chinese company, but the gist of it is, hey, thank you for dealing with us. If you have any problems, please don't go back to the source. Contact us first, and we want to make it right. So, nice, very well decorated, nice to meet you type of thing. These new batteries have the tabs already on them, so I'll figure that out. That's at least giving me something I can solder to. So let's get to it. When I put the original battery back in, since I had already broken the tabs off, anticipating that I'd be able to find one of these, I put it back, just soldered a piece of wire on there and soldered it to the tab that's already connected to the circuit board inside. I'm trying my best not to interfere with what's already in there. So this was temporary, and it worked. I would still get signals, especially on a cold day. Usually I'd get a signal really quick. Polarity is very important. I need to make sure that I orient these correctly so that the circuitry works. Now having this little tab already connected may be an advantage for me, because I won't have to put any heat on this new battery. I missed it. I'm using a GoPro. And this is the first time I've ever used this thing for producing a video. I'm finding out that the autofocus and the close focus is not real great, or maybe I just don't know how to use it. But anyway, I had to switch to this pony clamp because holding it with my hands, I was very close to stabbing myself a couple of times. Where this one was connected, when I tried to lift it, instead of the tab bending, it snapped off. So that means I'm going to have to dig all of this out and get down in there and get to the circuit board so that I can solder a wire on there. Now, I'm shooting this with my Galaxy smartphone, but right there is where the tab broke off of the circuit board. And what I did was I soldered a piece of bell wire on there, and I'm going to use that to connect to the battery. I'm going to put this little piece of electrical tape down there just to insulate the battery and the tabs from touching the circuit board. This wire right here, I'm going to skin that clean, and then I'm going to solder this battery in just like I did the other one. Uh-oh, what's going on with my light? Let's getting ready to blow up. I knew it wasn't going to last forever. It's jerry-rigged, but it'll work. Get me through the video. Here. Heat the material. Let the material melt the solder. And then don't disturb until it cools. A decent joint. Ow, that's still hot. Okay. Let's fold it over here, making sure that it does not touch the top, because that would be a direct short. And we don't. I believe that's going to work. Centrifugal force will be pushing down on this. Alright, now we will fold this sucker over, give it some tension. Let's put some heat to it and see what it does. And I'll have these tweezers in standby in case I gotta hold it while it cools. As a matter of fact, I think I'm gonna have to, because you want it to cool without moving. All right. It looks like crap, but functional, I'll say. At least I hope it is. Anyway, I'm gonna goop it up with some Flex Shot, smooth it out, then reinstall these suckers and see if it works. Alright, after all the smoothing, and let's see how much she weighs. The rear weighs 1.25 and the front weighs 1.25. I didn't upset the balance very significantly, so I'm going to put them back, then I'll balance my wheels and see how it works. They definitely don't look factory, but if they work, I will have saved myself a whole bunch of money. Tires are mounted back on the bike, and I'm ready to give it a test. Let's hope we did some good. Start the old girl up, and I'm gonna change my screen up here. Get rid of that, hit that, page, 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 and there we go. And that's the screen right there for the tire pressure monitors. And down here on my instrument cluster, I also have that set up. So let's give the old girl a whirl. Now we're gonna have to start rolling to wake them up. And I put 42.1 PSI in each tire. Let's see how it goes. Yet. And there it is. Wow, that was quick. Hope you got something out of this video. I enjoyed making it. This is the first time using my GoPro Hero9 Black. There's some things I like about it and some things I don't, but that's a whole nother story. Anyway, changing the tire pressure monitor batteries saves a significant amount of money. I don't know how long it's going to last. Hopefully until the next 7 years goes by. It's not difficult, but you need the tools. You need to be able to get your tires on and off. You also need to know how to solder. If you're not good at soldering, you probably want to practice that up a little bit. Once again, thanks for watching. This is Tony, and I do stuff. Okay, curiosity has got me. I figured since I had the batteries out, I grabbed some wire and some resistors. Figured I'd do a impromptu load test on the old batteries and compare them to the new battery, just to see what would come out. So here it is. And remember, I am not an electrical engineer. I am not a scientist. I'm just a guy that does stuff. And I'm curious. I've got my meter set up here to measure DC voltage. And I'm going to take a voltage reading on the front, rear batteries that I removed and a new one, just for comparison. So, the front one, well, I guess I should turn it around, huh? The front one reads 3 volts. The rear one reads 3.2. And the new one reads 3.298. Or, yeah, anyway, you see, 3.2. That's almost 3.3 volts. The next thing I'm going to do is I'm going to put a load on it. That's a no load voltage reading. That means the battery is not having to do any work. It's just providing the voltage, the force. So I have a 10 ohm resistor here, and I'm going to take it and wrap it around my meter probes. So basically what I'm doing is I'm putting a 10 ohm load across these batteries. And we're going to see what kind of current they can provide with a 10 ohm load on them. The front can provide just about 1 volt under that 10 ohm load. The rear, get back here. The rear, barely can do, it can't even get a volt out of that puppy. Okay. And the new one puts out 1.2. Okay, so the new one and the front one are pretty close. All right, now what I'm wondering is how much current is actually flowing in that circuit. All right, same situation with these two probes. This meter is still measuring the voltage across these, voltage across the batteries. This 10 ohm resistor is still in the circuit, but this meter is now set up to measure current in the circuit, and it's set to measure a maximum of 300 milliamps. I don't believe we'll get that because by Ohm's law, there's no way these batteries are going to put out 300 milliamps. But here we go. Oh. Just messed that up. All right, at 1.3 volts, we're drawing about 74, 75 milliamps. That's respectable, I guess. We have nothing to compare it to yet, except the rear one. Doggone it. In the rear, that 10 ohm load drops it below 1 volt, and we're pumping about 2 milliamps. 2.36 milliamps, which is nothing. This rear battery has no juice, no oomph. And let's see what the new one puts out. The new one stays at drops to 1.5 volts and is putting out 90, 89, 86. All right, it's got a respectable amount of current there. But it's dropping fast because we're loading it. So what we can determine from this is, yes, these two batteries are old and they don't have the current carrying capability or the current supplying capability of a new battery. So they're long in the tooth. This new one, it's got some juice. Let's see, it's had a moment to recover. Let's see what it's putting out now. Let's get this wire out of the way so we can actually read the meter. 1.4 volts, 80, 79, 76, and dropping. Yeah, we're pulling some juice out of it.